It seems like everywhere you turn these days, everyone's talking about computers learning, understanding language, I mean, it's wild.
Yeah, yeah.
You've got chatbots popping up left and right, algorithms deciding what we see online, even those smart assistants in our homes. It's all powered by this stuff, right? Machine learning, NLP.
Absolutely.
So for this deep dive, we've got our hands on some really fascinating material. Specifically, we're looking at excerpts from machine learning and natural language processing, core concepts.
Okay.
And then we're also diving into this more like in-depth report called Machine Learning and Natural Language Processing, a deep dive.pdf.
Sounds comprehensive.
Yeah, and our goal here is to give you a shortcut to understanding these, honestly, pretty complex fields. We want to unpack the key differences between ML and NLP, break down how they actually work, and most importantly, connect it back to why it should matter to you. Like, how is this changing the world around us? So think of this as your fast track to getting a handle on the core concepts of ML and NLP. We're going to highlight the essential processes, tasks, the influence of deep learning, how these models are actually used in the real world, what we need to watch out for, what the future holds, and even touch on some of the ethical questions that come up with this kind of powerful technology.
Yeah, and I think it's important to start by laying out the foundational differences between machine learning and natural language processing, right?
Yeah.
But also at the same time, we need to illustrate how crucially they're connected. They work together.
Exactly.
We'll definitely dig into the main types of machine learning, how they're applied, go through those typical steps involved in building these systems, explore some core NLP tasks and the specific machine learning techniques that power them. And then, of course, we have to talk about the impact of deep learning. I mean, that's been huge. We'll also touch on, like you said, the practicalities of actually deploying these models, considerations, strategies, all of that. And then, yeah, a little glimpse into the future. And of course, those important ethical considerations that we need to grapple with as this technology continues to evolve.
Okay, so let's just start with the basics here. For anyone listening, what really is the core difference between machine learning and natural language processing? And then how do they actually work together? Like, give us a tangible example.
All right, so at its heart, machine learning, ML, it's about giving computers the ability to learn from data, right?
Right.
But without us having to program every single step of the way.
Okay, so it's learning on its own, kind of.
Yeah, it's more about giving it the ability to identify patterns in the data, make predictions, and the really amazing thing is, as it sees more data, it actually gets better. It improves its performance.
Oh, that's interesting.
Now, natural language processing, NLP, that's more specialized. It's like a branch of AI that specifically focuses on giving computers the ability to understand, interpret, and even generate human language. So we're talking text, speech, all of that.
So it's like NLP is the language expert within the whole world of AI, and then ML is kind of giving it the tools to learn.
Yeah, exactly. And that's where their synergy becomes really powerful, right? NLP relies heavily on those ML algorithms, especially the more advanced deep learning models to do all sorts of incredible things.
Like what? Give me an example.
Okay, think about when you talk to your phone and it understands what you're saying. That's NLP at work.
Yeah.
Or when you use Google Translate to understand a website in another language. Or when you ask a question in a search engine and it gives you a relevant answer. All of those are NLP tasks that are powered by the learning capabilities of ML.
Okay, I see. So ML is providing the intelligence, so to speak, and then NLP is using that intelligence to understand and work with language. Pretty cool combination.
Absolutely.
Now, I know our sources talk about different types of machine learning, different ways these algorithms can learn. Can you break those down for us just so we have a good understanding of what we're dealing with?
Yeah, of course. So there are three main categories that you'll typically encounter: supervised learning, unsupervised learning, and reinforcement learning.
Okay.
Supervised learning is kind of like learning with a teacher, right? You're giving the algorithm labeled data. So you're showing it examples where you already know the input and the desired output.
Mm-hmm.
So for example, if you're teaching a model to recognize spam emails, you would feed it a bunch of emails that are already clearly marked as spam or not spam. The algorithm then learns the relationship between the content of the email and that label, whether it's spam or not.
Okay, so it's basically figuring out the rules based on the examples you give it.
Exactly. And this type of learning, it's really good for tasks where you have that clear answer key for your data. So like I said, identifying spam or classifying images, predicting specific outcomes.
Gotcha. So what about unsupervised learning? I feel like that sounds a bit more a bit more mysterious, maybe.
It is, in a way.
Yeah.
With unsupervised learning, you're giving the algorithm data that's not labeled. You're basically saying, okay, here's a bunch of data. Go find some interesting patterns or structures in it. But you're not telling it what those patterns should be.
So it's more about discovery, kind of.
Yeah, exactly. And a classic example of this is customer segmentation. You might give the algorithm data about customer purchases and can automatically group customers with similar buying habits together
Hmm. Oh, that's interesting. So companies use that to figure out like different customer groups.
all the time. Another application is dimensionality reduction, which is essentially simplifying complex data sets while still keeping the most important information. That's really useful when you have like a huge amount of data and you want to identify the key factors.
Okay, so supervised learning is about predicting specific outcomes. Unsupervised learning is about discovering patterns in data. And then we've got reinforcement learning. Isn't that like the thing that they use for those game playing AIs?
That's a good example. So reinforcement learning, it involves an agent, like a computer program,
Hmm.
learning to make decisions by interacting with an environment. And it gets rewarded for actions that lead to a good outcome and penalized for actions that lead to a bad outcome.
So it's kind of like training a dog almost.
In a way, yeah. Like if you're teaching a robot to navigate a warehouse, it gets a reward if it moves closer to the correct shelf and a penalty if it bumps into something or goes the wrong way. And over time, it learns to navigate the warehouse more effectively to maximize those rewards.
Okay, that's really cool. So those are the three main types of learning. Now, let's say we want to actually build one of these ML or NLP systems, the kind of things that are affecting our lives every day. What are the typical stages involved in that process?
Well, there's a general process that both fields tend to follow, but of course there are some adaptations depending on whether we're talking about ML or NLP. So for machine learning, it typically starts with data collection. You need to gather all that relevant information that your model is going to learn from.
Right, so you need the fuel for the engine.
Exactly. Then comes data preprocessing, and this is really important. It's about cleaning the data, transforming it, organizing it into a format that the algorithm can actually use.
So you're getting it ready for the computer to digest, basically.
Yeah, you're making it palatable. And then comes the fun part, model selection. This is where you choose the right ML algorithm for the job, based on the task you're trying to accomplish.
Ah, so this is where the expertise comes in, figuring out which tool to use for the job.
Absolutely.
Yeah.
And then you move on to model training. This is where the algorithm actually learns those underlying patterns from all that preprocessed data. And then, just as important, you have model evaluation. You need to test how well the trained model performs on new data that it hasn't seen before.
Oh, that's interesting. So it's not just about learning the patterns in the data you give it, it's about being able to generalize to new data as well.
Precisely. And finally, if the model performs well enough, you move on to model deployment. This is where you integrate it into a real-world system so it can actually do something useful, make predictions, make decisions, whatever the goal is.
Got it. So that's the typical process for ML.
Yeah.
How does it differ for NLP?
Well, it mirrors the ML process in a lot of ways, but obviously we're dealing with language data, which is a bit different. So it starts with text acquisition, gathering all the text data we need. Then we move on to text preprocessing, which involves cleaning and normalizing the text. So this might include things like removing those really common words like the, a, an, which don't really carry much meaning. We call those stop words. And then there's stemming or lemmatization, where we reduce words to their base form. So like running, runs, ran, all become run.
Right, so you're simplifying the language, making it easier to work with.
Exactly. But then comes a key step that's really unique to NLP feature extraction. This is where we convert the text into a numerical representation that those ML algorithms can understand.
Wait, so you have to turn the words into numbers?
We do. And there are different techniques for doing this, like bag of words, TF-IDF, and more recently, these advanced word embeddings, which really capture the meaning of words and their relationships to other words.
So it's not just about counting words, it's about understanding the deeper meaning behind them.
Exactly. And once we have those numerical representations, the rest of the process is quite similar to ML. We have model training, model evaluation, specifically tailored for NLP tasks, and then model deployment into applications that people can actually use.
Okay, that makes sense. So the big difference in NLP is really how you prepare that language data and get it ready for the ML algorithms to work their magic. Now, earlier we were talking about some of those fundamental NLP tasks. Can we dive a little deeper into those? I'd love to understand how those ML techniques are actually being used in practice.
Absolutely.
Yeah.
So let's start with the most basic one, tokenization. This is literally breaking down text into smaller units, usually individual words or phrases.
Okay, so like separating a sentence into its individual words.
Exactly. And while that might not sound very glamorous, it's a crucial first step. Then you have part of speech tagging. This is where we figure out the grammatical role of each word in a sentence. Is it a noun, a verb, an adjective, and so on. And this often uses sequence labeling ML models that can learn the patterns of language structure.
So that's how the computer understands grammar, essentially.
In a way, yes. And then there's named entity recognition, which is about identifying and classifying specific entities in text, like names of people, organizations, locations. And this usually relies on supervised learning models that have been trained on data that's already been labeled with these entities.
So like when an algorithm automatically picks out all the company names mentioned in a news article, that's named entity recognition.
Exactly. And then we have sentiment analysis, which is all about figuring out the emotional tone of a piece of text. Is it positive, negative, or neutral? And this often uses text classification ML algorithms trained on labeled data, like customer reviews that have already been tagged as positive or negative.
Okay, so that's how companies analyze social media posts to see how people feel about their brand.
Exactly. And then you have machine translation, which has been absolutely revolutionized by deep learning, especially with these new transformer networks. Text summarization, where we try to create concise summaries of longer texts, uses both extractive methods, which pick out key sentences, and abstractive methods, which generate new sentences that capture the essence of the text. And both of these rely on ML techniques. Question answering systems, which can answer your questions in natural language, often use models trained on vast amounts of text data. And finally, text classification in a broader sense, like categorizing emails into different folders or classifying documents by topic, also uses various supervised learning algorithms.
Wow, that's a lot of different tasks. So the key takeaway here is that ML is really the engine behind all of these NLP capabilities, allowing them to learn from data and perform these tasks effectively.
That's it.
Now, our sources really emphasize the impact of deep learning on NLP. Can you talk a bit more about that? Like, how has deep learning changed things compared to the more traditional ML approaches?
It's been a game changer. Traditionally in NLP, we relied a lot on manual feature engineering. So experts would have to manually identify and create relevant features from the text data, things like counting specific words, calculating TF-IDF scores, and so on. And then they would feed this structured data into more traditional ML models like naive Bayes or support vector machines.
It still was a very manual process, like handcrafting those features.
Yeah, very labor intensive. But deep learning has essentially automated a lot of that feature extraction process. So now we have models like recurrent neural networks, RNNs, and more recently, these transformer networks like BERT and GPT that can automatically learn those complex patterns and hierarchical representations directly from the raw text data.
So it's like instead of us having to tell the model what to look for, it can figure out those important features on its own.
Exactly. And that's led to huge advances, especially in areas like machine translation, text generation, and question answering. Deep learning models can capture the context of language much better than traditional methods. They understand how the meaning of a word can change depending on the words around it. They can even understand relationships between words that are far apart in a sentence.
That sounds incredibly sophisticated. Like it's getting closer to how humans actually understand language.
It is, and that's why we've seen such a dramatic improvement in the performance of these NLP systems.
Okay, so deep learning has really pushed the boundaries of what's possible with NLP. But now, let's talk about how these powerful models actually get used in the real world. What are some of the key things we need to consider when deploying ML and NLP models?
Right, so deployment is a whole other challenge. There are several crucial considerations. First, you have performance requirements. How quickly does the model need to make predictions or give responses? How accurate does it need to be for its specific purpose?
So those are the basic performance metrics.
Yeah, nuts and belts. Then you have scalability. Can the infrastructure supporting the model handle increasing amounts of data and users as the application grows? You also need to ensure reliability and availability. You don't want the system crashing all the time, right? And then monitoring is essential. You need to track how the model is performing over time and detect any potential issues, like data drift, where the nature of the data changes and the model's accuracy might decline. Security is also a major concern, especially when you're dealing with sensitive data. And finally, there's the cost. You need to be aware of the expenses related to infrastructure and maintenance.
It sounds like a lot to juggle. So, what are some of the strategies for actually getting these models deployed into real-world applications?
There are a few different approaches. You have batch deployment, which is basically processing data at scheduled intervals. That's good for things that don't need instant results, like generating reports. Then you have real-time deployment, which is essential for applications that need to respond immediately, like fraud detection systems or those recommendation engines you see on websites.
Right, so you need different deployment strategies depending on the speed and responsiveness required.
Exactly. And then you have containerization, which is about packaging the model and all its dependencies into a portable unit that can be easily deployed across different environments. Serverless deployment, using cloud functions, can be very cost-effective because it automatically scales resources based on demand. And then for rolling out new versions of a model, you have strategies like canary deployments, where you slowly expose the new version to a small group of users first, and blue-green deployments, where you maintain two identical environments and switch traffic between them to minimize disruption.
Okay, so there are a lot of different ways to get these models out there and working for us. Now let's look ahead a bit. What are some of the trends that you're seeing that are likely to shape the future of ML?
Well, one big one is explainable AI, or XAI. This is all about making the decisions of these complex models more transparent and understandable to humans. As AI becomes more integrated into our lives, it's becoming crucial that we understand why a model is making a particular decision, for trust and accountability.
Right, because these black box models can be a bit unsettling if we don't know how they're arriving at their conclusions.
Exactly. Then you have automated machine learning, or AutoML. This is about simplifying the development and deployment of ML models, making it more accessible to non-experts by automating tasks like data preprocessing and model selection. Generative AI is another exciting area where models can create new data instances like images, text, music, even videos. Federated learning is gaining traction as a way to train models on data that's distributed across multiple devices without compromising privacy.
So that could be really useful for training models on data from smartphones, for example, without having to collect all that data in a central location.
Exactly. And then further out on the horizon, you have quantum machine learning, which explores how quantum computing could potentially speed up certain ML tasks. Continuous learning is about developing models that can constantly learn and adapt to new data without forgetting what they've already learned. And then there's a growing emphasis on human-centered AI, which is about making sure that these AI systems are designed and used in a way that aligns with human values and needs.
That's really important considering the potential impact these technologies can have on our lives.
Absolutely.
So, as we wrap up this deep dive, what are the key takeaways you want our listeners to walk away with?
I think the biggest one is that machine learning and natural language processing are incredibly powerful and intertwined fields that are going to play an even bigger role in our lives going forward. ML provides the learning capabilities, NLP uses those capabilities to understand and process language, and together they're enabling all sorts of amazing applications. We've talked about the different types of learning, the NLP tasks, the impact of deep learning, the challenges of deployment, and some of the exciting trends that are shaping the future.
Yeah, it's been a really fascinating journey, and I think you've given our listeners a lot to think about.
I hope so.
So, as you consider all those trends we discussed, like explainable AI, generative AI, federated learning, all of that, I want to leave you with this thought. Which of these trends do you think will have the biggest impact on your life, on your work, on the world around you? It's worth taking some time to ponder that
Definitely.
because one thing's for sure, the world of ML and NLP is constantly evolving, and there are endless opportunities for learning and discovery along the way. Thanks for joining us for this deep dive.
Thanks for having me.